In this video, we are going to learn how to graph sinusoidal functions using these transformations. Now, first I want to start out is that these are wave-like functions, so they have amplitude and period. And we usually use these same terms for all the trigonometric functions. Now, the way you find amplitude is usually the number that's multiplied out in front of the trig function. And you take the absolute value of that number, and that'll tell you the amplitude of the graph. I'll explain why that is later. And the period of the graph is typically your period of the function divided by omega, the variable in front of the x value inside of the trig function. And the only reason I'm putting t here is that you need to simplify this to find the period. So let's start with our first example. We're going to determine its amplitude and period first, and then we're going to graph the function using key points like I discussed in the last video. So the amplitude of this graph takes that 3 that's out in front and takes the absolute value of it, which is 3. So the amplitude of the graph is 3. Next up, the period is I take this 4, which is the omega value, and I take 2 pi and divide it by 4, and I get pi over 2, which means the period of this function is pi over 2. So now, the graph is using key points. I first wrote down my 5 key points for sine, and now I'm going to apply the period change first, which means usually this would start at 0, but now, instead of ending at 2 pi, it end at pi over 2. So now, the way you graph using these key points is we now need to evenly distribute this period amongst all the points, which means taking that period and dividing it by 4 into 4 equal parts. So pi over 2 divided by 4, which is the same thing as multiplying by a fourth, would be pi over 8. So I'm counting by pi over 8 for every single point. So 0 plus pi over 8 is pi over 8. Pi over 8 plus pi over 8 is 2 pi over 8, which is pi over 4. And then 2 pi over 8 plus pi over 8 is 3 pi over 8. And 3 pi over 8 plus pi over 8 is 4 pi over 8, which is pi over 2. You'll see here I didn't affect my y values because that's not what the period changes. It just changes these x values. Now, this 3 is the amplitude change, and that's what I'm going to multiply each of my y values by to figure out where my new point is going to go. So if I take 0 and I multiply it by 3, I'll get 3. This next point, I'm not changing the x value. I'm just changing the y value. Oh, sorry, 0. 0 times 3 is 0, not 3. But now 1 times 3 is 3. Again, not changing my x values, keeping those the same. 0 times 3 is 0. And negative 1 times 3 is negative 3. And pi over 2 stays the same. And then 0 times 3 is 0. So now I have 5 points to graph with, and I can repeat this pattern as many times as I need to on the graph. So 0, 0 is where it starts. Now, pi over 8 isn't a tick mark on here, but I already know that I have to repeat myself every pi over 2. So I have these little moments in between, so everything can be represented. So at pi over 8 is between 0 and pi over 4, halfway between, and it's 3 there. Then it's back to 0 at pi over 4. Then it's negative 3. Then back to 0. And if I were to draw this, it would be a very tall wave. And it can repeat this pattern over and over again. So again, putting these little points in between, it would be 0, 3, 0, negative 3, 0. And I can draw it again. And typically, if you can, about 3 cycles is enough. And I often like to try to go backwards with it as well so you can get a good idea. So again, if this was 0 going backwards would be negative 3. then 0, then 3, then 0. That peak looks a little strange, but this is a very tough one because it's so steep. And there. And this would continue on forever in both directions. Next up, we're going to look at 2 sine of negative 2 pi, negative pi over 2x. So to start this one out, we're using even odd property. Since this is an odd function, this negative on the inside can be factored out. Give me y is equal to negative 2 sine of pi over 2x. And it's just a really good place to start. Anytime you can take out a negative from one of the trig functions, definitely do it. And if it was cosine, that would just disappear. It wouldn't even be taken out. Now the amplitude of this graph would be the absolute value of negative 2, which is 2. So that's done. The period, on the other hand, will be 2 pi divided by pi over 2. Now, simplifying that to make it a little easier to see, it's 2 pi times 2 over pi. I divide by a fraction. So the pi's cancel, and 2 times 2 is 4. So my period of the function will be 4. Now to go over again, sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, and sine of 2 pi is 0. Again, knowing those key points is going to make the rest of this process a lot easier. Because now I'm going to apply just the period change first. So sine of pi over 2x. So all my y values should stay the same. They aren't going to change. But my period I know now is 4, so I'm going to go from 0 to 4. And then in 4 equal parts, 4 divided by 4 is 1. So 0, 1, 2, 3. So very easily, I got those. And again, those are going to stay the same in this next step. Because now I'm going to apply the negative 2 that's out in front of the sine function. Because now that negative 2 will be 0 times negative 2, which is 0. 1 times negative 2, which is negative 2. 0 times negative 2, which is 0. Negative 1 times negative 2, which is positive 2. 0 times negative 2, which is 0. And now I should have all the points I need to graph this. 0, 0, 1, negative 2. 2, 0. 3, positive 2. 4, 0. And I could continue this same pattern. So first I'll just draw it out so you can see one cycle of the sine function. And again, if I follow that same pattern, it went from 0 to negative 2, 0, 2, 0, negative 2. And I can't quite fit 3 cycles on here, but I'm going to fit as much as I can. But going backwards, it'll be from 0 to positive 2, then back to 0. That's the graph of y is equal to 2 sine of negative pi over 2x. Now, the last one we're going to do is negative y is equal to negative 4 cosine of pi x minus 2. And we're going to talk about what this minus 2 means with this next example. But starting out, I want to find my amplitude and my period. So my amplitude is going to be absolute value of negative 4, which is 4. So my amplitude is 4, so it's going to go as high as 4 and as low as negative 4. And then my period is going to be 2 pi divided by pi, which is 2. And then I'm going to use that 2 to figure out my key points. Now starting out, cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is negative 1, cosine of 3 pi over 2 is 0, and cosine of 2 pi is 1. Again, for this first step, I'm only going to be changing the period of my function, so it will be cosine of pi x. So just this period change only, so my y value should stay the same as I go throughout this step. But now I know my period goes from 0 to 2, so divide that up into 4 evenly. That would be 1/2, 1, 3/2, and then 2. And again, that should stay the same for the rest of this problem, because that's the only change I have to x is with that period. Now let's look at this y change. I'm first going to start with the negative 4 out in front. So the negative 4 cosine. So 1 times negative 4 would be negative 4. 0 times negative 4 is 0. Negative 1 times negative 4 is 4. 0 times negative 4 is 0. And 1 times negative 4 is negative 4. Now the reason why I'm starting with the negative 4 is order of operations. I'm taking this cosine value and it's being multiplied by negative 4 first, and then we're subtracting 2. Because now that I got this, I'll then take care of the minus 2 part of the function. So negative 4 minus 4 would be negative 6. 0 minus 2 is negative 2. 4 minus 2 is 2. 0 minus 2 is negative 2. And negative 4 minus 2 is negative 6. So as I go to graph this, I have my first point at 0, negative 6. So this is 5, so negative 6 would be somewhere down here. And then I have 1/2, negative 2. And then 1, 2. And then 3/2, negative 2. And then 2, negative 6 was again some point down here. And then if I continue the pattern, the next half would be up again at negative 2. Then at 3 it would be 2. Then back to negative 2. So we're starting to see this pattern form. Again, let's follow the same pattern backwards. I can see here at negative 1/2, it should be at negative 2. At negative 1, it should be 2. At negative 3/2, it would be negative 2. Then at negative 2 would be down to negative 6. And then negative 2 again. And I can create the same sort of pattern. And that is the graph of y equals negative 4 cosine of pi x minus 2. And this is how you graph sinusoidal functions using transformations.